Okay, so welcome to your actual first video for your flip class. Today we start chapter 3, which deals with linear equations and linear inequalities. And we will be looking at multiple representations to write an equation of a line and to graph a line. We will also be looking at problems where we have to identify a situation that would represent a constant increase or a constant decrease situation. This word constant is going to be very key, especially throughout this chapter and as we go through this book. Constant automatically relates to line. You'll hear what's called a constant rate of change, and maybe some of you have heard of that or you've heard of slope. So we are definitely looking for a constant increase and a constant decrease throughout this section and this chapter. But again, we're going to be looking at multiple representations, so it may be a graph, it may be an equation, or it may be a table that we look at. So what I first want you to do, we're going to read through this problem because I want you to see where is this going, how does it relate to the big picture. So yes, we're going to be able to do these problems, but what's that going to look like and what kind of problems will we be seeing throughout this section? So what I have highlighted down here, this is kind of the overall goal. We're going to have this problem. We want to create an equation that models this situation. So we are coming up with that equation, and then we're going to graph that relationship. So the situation we will graph. We may be able to even graph it from the equation. Maybe we'll make a table. But what I want you to do is go ahead and stop the video, read through this, so you get an idea of where we're going and what I expect you to be able to do by the end of this section and what we will work on in class tomorrow. Okay, so as I said, we'll be using the concepts learned in this section and throughout this chapter to answer or solve problems similar to the one you just read. So let's look at a couple of terms here. We have what's called a constant increase situation. So this is something I want you to be able to determine if we have. Do we have a constant increase situation? So what is that? What does that mean? That word increase, grow, gets bigger. So a constant increase situation is a quantity that increases or grows at a constant rate. So when we say constant rate, we just mean the exact same amount. But again, there's that word constant, exact same amount. So as x increases, y also increases. And as x decreases, y decreases. So what do I mean by that and what does that look like? So let's look graphically for a minute. We'll have a coordinate plane here. So, as x increases, y increases. So as x gets more and more positive, gets bigger and bigger, y is also getting bigger and bigger or more positive, going in the positive direction. So as x gets bigger or increases, so does y. So it takes on this shape. As x gets smaller or more negative, y is doing the same. So it takes on this shape. Now when I connect these points, I'm going to have what looks similar to a line, but notice as x gets bigger, y gets bigger. So whatever x is doing, y is doing. They're moving in the same direction. X gets more positive, y is getting more positive. It is growing at a constant rate every single time. Also notice we're going uphill from left to right. Keep that in mind as we go. And maybe some of you are thinking, hey, that looks like a positive slope. You're right. A constant increase will result in a positive slope. So we're talking about this x and y, and I just want to recall a few terms and a little bit of information. X is considered the independent variable, and y is considered the dependent variable. So remember, when we have equations or tables, x, we let it be whatever it wants to be. That's the number we're plugging in. The outcome y depends on x. The outcome is determined by whatever we plugged in for x. So remember, x is independent, it can be what it wants. Y, the outcome, depends on x, so hence it's the dependent variable. So domain is also considered or refers to the x values. Remember, range refers to the y values, so maybe one way to think of it is domain and range. Domain starts with D, range starts with R. D comes before R in the alphabet, and X comes before Y in the alphabet. So just a couple of quick little reminders here. because you'll be expected to determine the domain of a given situation. So we went over constant increase, so what is constant decrease? Decrease gets smaller, so constant at a constant rate. So this is a quantity that decreases or goes down or decays, that's another word go here, at a constant rate. So again, there's the word constant, and again, that just means the exact same amount So with this situation, as x increases, y decreases. As x decreases, y increases. So if you notice, the values of x and y are going in opposite directions. So what might that look like? So as my x gets more positive, my y is getting more negative. It's going down, it's getting smaller. So it takes on a general shape like so. So as x gets more positive, y gets more negative. As x gets more negative, y gets more positive. So as x decreases, y is increasing. To look something like this. X is negative, y is positive. More negative, more positive. More negative, more positive. So again, we have this linear situation, something that looks like a line. So notice it's going downhill from left to right, and maybe some of you are thinking that's a negative slope. You are correct. Constant decrease will result in negative slope. And we will talk more about slope and how that affects the shape of a line later this year. But for right now, maybe that's something you're familiar with and you could apply it to this. But in general, constant decrease, your x and y values are going in different directions. Constant increase, they're going in the same direction. So we can represent these constant increase or constant decrease situations as a table. So think of your XY table, your input, output. A graph, so similar to what I was just showing you. So if we have a table, we have points that we can plot. Or an equation. So each one of these would be a way to represent a constant increase or a constant decrease. You are going to hear this word collinear, and you'll see it again in geometry. So when we say collinear, we just mean points that lie on the same line. So when I was plotting those points and then I drew a line through them, all of those points would be considered collinear because they were all on that exact same line. So this just means points that lie on the same line. So if you're asked if points are collinear, that just means would all those points lie or fall on the same line. Okay, so let's go ahead and look at a couple of examples here. The first one being tables. So we're going to decide if the table determines a constant increase or a constant decrease situation, or maybe neither. So when we do this, when we have a table, we want to break it down. We want to look just at my x values. Are they increasing or decreasing by the same amount, a constant amount every single time? And then do the same thing for your y's. And then we will compare overall, do we have a constant increase or a constant decrease, or neither situation? So let's look at our x values first. Obviously we're increasing, the numbers are getting bigger, 1 to 3, 3 to 6, and so on. So how do I go from 1 to 3? I'm adding 2. 3 to 6, I'm adding 3. 6 to 10, I'm adding 4. 10 to 15, I'm adding 5. Okay, so is this increasing by the exact same amount every single time, a constant amount, a constant rate? No, because I'm adding 2, then I'm adding 3, then 4, then 5. So yes, it's a pattern, but it is not representing the exact same amount every single time. So this is not a constant increase. Let's look at the y's though. 2 to 5, 5 to 8, 11 to 14. So yes, it's increasing, it's getting bigger, but is it constant? 2 to 5, we can add 3. 5 to 8, we can add 3. In between each one of those, and we always want to check all values, we're adding 3. So is this increasing at a constant rate? Yes, because it's increasing by 3 every single time from one value to the next. So even though my y's are increasing at a constant rate, my x's are not increasing or decreasing at a constant anything. So because of that, this represents neither a constant increase or a constant decrease situation. The x values kind of mess it all up. So this is neither, and that is because your x values are not showing a constant increase. So let's look at the next table. My x values are getting bigger, so we know increase, but is it increasing by the same amount? From 100 to 200, 200 to 300, 300, 400, 400 to 500. So what's happening every single time? We're adding 100. And yes, you need to check every single set of values, because if you don't, these two, maybe they increased by the same amount, but then the next one didn't. So make sure you check that it is going to be constant from one value to the next. My y's then, they're going down, they're getting smaller. So let's see if it's a constant decrease. Does it decrease by the same amount every single time? So what am I decreasing by to go from 100 to 87? Well, I can pick up a calculator if I'm not sure. 100 minus 87, and we get 13. And again, it's going down. We're subtracting 13 from 100 to get 87. So let's see if that remains. Can I take 87 minus 13 and get 74? Yes. 74 to 81 or 61. Subtract 13 again. 61 to 48. But again, you're checking every single value. So we are decreasing by a constant amount because we are subtracting 13 every single time. This is a constant amount, the same amount every single time. Notice though, my x values are increasing by something, my y values are decreasing by something. So it's okay that that is not the exact same amount. So just because my x values increase by 100, my y values do not have to increase by 100. So we look at them separately, and then we're going to check out overall constant increase or constant decrease. So the x values are increasing at a constant rate. They're getting bigger. My y values are decreasing at a constant rate. They're getting smaller. So let's think about that. As x gets bigger, y gets smaller. Their values are going in opposite directions. So is that a constant increase or a constant decrease? If you go back and look at your definitions, this is going to be a constant decrease. X and y are not doing the same thing. As one gets bigger, the other gets smaller. And maybe you kind of are tying that into what would that look like as a graph? Okay, so I'm going to start this one for you, but you will finish it. Suppose Madison begins with $500 in an account and adds $20 per week. We are going to complete this table showing T the total amount Madison will have at the end of W weeks. Let's go back to the prompt and pick out what is key information. She starts with $500. She is adding $20 per week. So would this be a constant increase or a constant decrease situation? Constant increase, we are adding. Why is it constant? Because we are adding the same amount every single week, the $20. Okay, so we're hopefully thinking, we're pretty sure this is probably, well, it is a constant increase because, yes, we're increasing by the same amount every single time, every single week. Remember, we have an XY table, although we have different variables, W and T, but this is still an input-output table, so if you like to think of it as X and Y. But at week 0, how much money do we have? So as we start, what do we have? We have $500. After week 1, we have the $500 plus that $20. So $520. We're going to add $20 more to that for the following week. And so on. Another way to think of it is, okay, I started with $500, and then I added $20 after week 1. I started with $500, and then I added $20 each of those 2 weeks, so plus 20 times 2. So 500 plus 40 is still 540. So that pattern continues. We are increasing by the same amount every single time. So what you are going to do, you're going to go ahead and finish this table. Don't forget, a table gives you points to plot. So boom, 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 boom. So that's an actual order pair that you can plot, 0, 500, 1, 520. And I'm kind of pointing it out for a reason. So finish the table. Then you are going to work on and finish pretty much the rest of this example. Answer these questions. You are graphing the order pairs from the table that we just started. So again, remember this WT, that's in the spot for X, this is in the spot for Y. You are plotting those ordered pairs, and you're going to see what shape it takes. You must do this on graph paper, and you must label each axis. So what does your x-axis represent? What does your y-axis represent? Make sure you attach that to the notes. Also, let me know what intervals are you counting by. So what are you counting by in your x-axis and your y-axis? Then, what you are going to do, you're going to write an equation that represents t in terms of w. So basically, what's an equation that's going to represent that total amount of money, no matter how many weeks we keep adding $20? And then finally, what would the domain of this situation be? So what are those possible input values? So that's what you're going to finish up, and you're going to do one more thing for me. At the beginning of the notes, back on page 1, we had a situation that you read, and I want you to go back, read it again, and off to the side here, I want you to tell me, does this represent a constant increase or a constant decrease situation? So just write that down off to the side, what you think the best answer is, and then be able to explain why you said it was a constant increase or a constant decrease. So that's everything that I'm looking for tomorrow, and we will work on more problems like this in class. See you tomorrow.